Okay, so what I want you guys to think, this is a very tricky example. That's why I want to go over it during class. You have already seen a bunch of different exercise examples in the PowerPoints in this week's videos. And so I want to do something different. And I know setting up a non-alternative can be really tricky. Whenever I teach hypothesis testing, I know a lot of students are having problems. So that's why I want to use this as a demonstration. I think this is a challenging exercise, challenging example. Okay, I think I pretty much have everyone is back. Okay, so let's take a look how we can solve this problem. So first thing is you always ask yourself what kind of a data is. I think almost all groups were able to see this is a categorical variable. And the reason is because we are talking about supermarket shoppers who believe this supermarket brand is as good as a national brand, right? Or maybe I think they were using plural form. Supermarket brands are the same as good as national name brands. So generic versus the name brands. So 64% who believe it. So you can classify shoppers. Okay, hold on a second. You can classify shoppers as yes or no. So yes means those people who believe they are the same. So typically we assign a 1, and if it's no, we assign 0. So this is about 64%. So that's a categorical data. And what we want to do next is we want to set up this non-alternative, and we have the now here an alternative because this is a categorical variable. If it's a categorical variable, we know it's gonna be P here and P here, right? P and P, this part is easy. So writing up the non-alternative can be a little bit tricky, and I like to start from the alternative. So this is our research question. This is something that we try to test. We try to see whether it is true or not. So what is that thing we try to see? Okay, anybody wants to give it a try? This is a little bit challenging. I'm going to help you here. So what are we trying to determine here? What are we trying to determine? Who wants to give it a try? So we want to see whether the percentage or proportion of shoppers who believe the supermarket ketchup is as good as the national brand ketchup. Okay, so what are we trying to determine here? We try to determine the proportion. We try to compare this population proportion with something else. What are we comparing with? We compare P with Benjamin. I think you were right. So what is the P we're comparing with? I'm comparing P with, what am I comparing P with?
0.64.
0.64, right? You're absolutely right. So we want to see whether, okay, this proportion, we compare it with 64. Okay, so maybe you can help me a little bit further. Okay, so what kind of an inequality sign I should place here and here? I'm going to start with the alternative. So we want to see P, we compare P with 64%. What do you think I should put down here then?
Does not equal.
Not equal to, right? The keyword which I also highlight here, different, or maybe, the different version, or maybe not the same. Those are the keywords it should help you to determine this is not equal to, very, very important. And so similarly, you can deduce this is going to be equal to. So what kind of a test is this? What kind of a tailed test? This is a two-tailed test, right? Two-tailed test is very, very tricky, very, very tricky. And the reason is because when you deal with a two-tailed test, you're going to have a positive, sorry, I know a lot of people do not know what this is, so I will try not to use that short form. Okay, so you are going to have a positive critical value. You are also going to have a negative critical value. So two different critical values. And when you calculate the p-value, you would have to use 2 multiplied by a probability. So this part is really tricky, very, very tricky. Okay, so I know my time is running out a little bit. So I'm just going to quickly fill in here. Population proportion. We do not know this one. That's why we try to test. And sample proportion here is 100 shoppers, 52 of them stated yes. Okay, so you can fill in here. Sample proportion is going to be 52 over 100. That's going to be 0.52. And sample size is going to be 100, right? And significance level, I think here it says 1%. So that's going to be 1%. And is it z-test or t-test? And hopefully you guys all agree with me. That's going to be a z-test. The reason is because this is a categorical data, so you can only have a z-test. And test statistics. So this part, all you need to do is plug them into your formula you have. So this is a z-score, Okay, that's going to be p bar minus p0. P0, make sure you are using p0 here. If you plug in all the numbers, what number do you guys get? Maybe some other groups were able to calculate. What test statistic were you able to get? It's a negative number. So were you able to get negative 2.5? Any group, any student? Raise your hand if you did. Minus 2.5. Okay, good. Okay, so this is right. Okay, so you were also asked to find a p-value. Okay, so p-value. Okay, so I'm just gonna calculate it for you. So I'm gonna label out a negative 2.5 here, a positive 2.5 here. So p-value, okay. So in order to do this, what you need to do is, this is the null. To be considered close enough to the null, it can be to the left, a little bit to the left, or maybe a little bit to the right. You cannot go beyond those test statistics you have here. So the test statistic we have negative 2.5, but you can also derive another positive test statistic, which is equally far away from the test statistic we have to the null. So that's why you use two of those. Okay, the p-value is just gonna be the area here and here. Due to the symmetry of this curve, you just have to calculate one of those and then multiply by 2, right? You just have to calculate one of them. So I'm just gonna write it down here. It's gonna be 2 times probability z to the left of a 2.5. So what I'm referring to here is just this one. And if you do that, you can use your table to find it. And that's just gonna be 0.0124. So you want to compare this p-value with your alpha. I think alpha is given to be 1%. So this is actually higher than the alpha. This is alpha. Okay, so you fail to reject. In case you want to try it using critical value, you can also try it out using critical value. So critical value is going to be plus minus 2 of those because it's a two-tailed test. Unfortunately, I don't have the answer right here, but let me see. I think maybe I can give you the number right away. Give me a second. I'm looking at my table. Okay, I think it's plus minus 2.575. So you can double check this later on. Check your answer later on to see whether you're able to get this one. I'm almost done. Okay. So therefore, there is or there is not enough evidence to reject it. Okay. So because you fail to reject it, so there is not enough evidence to believe. Okay. So the very last question you want to answer: should the national brand ketchup manufacturer be pleased with this conclusion? Should they be happy or not? So from this hypothesis testing, what we learn is we fail to reject a null. We fail to reject a null. If we fail to reject a null, that means the null is right. So we fail to reject a null, so that means the null is right. So that means P is about 64%. So P equals to 64%. If it's indeed about 64%, that means quite a lot of people don't think the generic or maybe the supermarket brand is the same as the national brand. So only 64%, let's see, only 64% shoppers believe supermarket ketchup is about the same as the national brand. So do you think they should be happy or not? Only 64% of them think it's about the same. So do you think they should be happy or not? If it's 99% or maybe 90% of the shopper believe the supermarket is as good as the national brand, they should not be happy because they should not produce the national brand manufacturer should not produce that. They should just produce a generic or maybe supermarket brand, which is probably called like cheaper and more efficient. And not only 64 of them actually thinks they are about the same as that. So they should be happy, right? They should be happy. Yes, they should be pleased. Okay, they should be pleased. They should be pleased because only 64% of the shoppers think the supermarket ketchup is as good as the national brand. So that means quite a lot of people actually don't think so. 36 of them. I mean, if you argue the oppositely, as long as your reasoning is right, it would be graded right as well. Okay. Any questions for me? And again, the answers, type of the results will be posted on Canvas right after this class. And the video from today's lecture will also be posted there. Questions from you guys? Okay. Well, make sure you work on the practice midterm. Very, very important. I couldn't, emphasize anymore. And I don't want to repeat myself too many times. Make sure you work on that one. And if you have time, try out the ungraded engagement assignments and email me if you have any questions, right?